Okay, let's try to get started. My name is Jakob, and I work at a company called BERT. We're a Swedish startup in the ad tech industry, doing ad analytics. And well, being a startup these days means that you're usually following some lean principle, like running a lean startup. And we're doing agile development and promoting agile advertising for our customers. And we're using dynamically typed programming languages and Scrum and everything. Everything is just so fucking dynamic all the time. Except for one tiny, tiny thing. JavaScript is not. And sure, JavaScript is dynamically typed, but it's not really a dynamic programming language. So I will use this talk to describe what I mean, to make you understand my thoughts here. But I will start by explaining how I came to this conclusion, or rather, which experience took me through this. I started developing in high school, and I learned that static checking was good because I was programming C++, a horrible first language. And I read all the books by Bjarne, in particular the Design and Evolution of C++, which goes into the detail of the language itself, and this made me interested in languages. But the theme, kind of one of the things that really stuck with me was that casting was evil, because casting a variable from one type to another was a design flaw. You've made some mistake in your code since you have to change something from one thing to another. And I thought this for years, and I programmed C++ for maybe 3, 4, 5 years without learning any other languages. But later I got some new perspectives when I got into web. I learned SQL, I learned PHP, Perl, all these wonderful things. And in particular, I discovered Haskell. And if there are some people here who don't know what Haskell is, it's a purely functional programming language, which is statically typed, but all the types are inferred. So you almost never have to write the types, but still the program will, or the compiler will tell you if you've done something inconsistent. And I thought, hey, this is cool. But Haskell is purely functional, and that makes it hard to use and think like you usually do. So I thought, why not take the ideas from Haskell, this type inference, to some language that is, well, more useful in general. And since I started doing some web development, I had recently learned JavaScript and found it to be a nice little language. And it should be possible to put like a type inference layer on top of JavaScript, was my idea. So let's combine the best of two worlds, like type inference and a tiny, very useful language. And the idea was good, but the problem was that there are some features in JavaScript that you can't really infer at runtime, or at compile time, I mean. So the project was bound to fail. I mean, it's not possible to do static checking on eval, on with, on looking up keys in an object using a string rather than the dot notation and so on. And I thought that, well, that wouldn't matter much because those features are kind of creepy, right? You shouldn't really use eval, and with, that's, no, that's bad. But the reason it failed, the reason I couldn't just exclude those things, were that most libraries actually use one or another somewhere deep in the code. And if you can't statically check your libraries, you can't statically check your own code, and the whole thing breaks. So it didn't work. But it made me realize that the real benefit of a dynamic programming language is not that, ooh, I don't have to write the types. It's so easy. I don't have to think. I can just experiment, and we'll see if it blows up at runtime. The real benefit is that it allows you to do certain things that you can't do in a static language. And I mean can't. It's impossible. Like, doing the eval things and with and so on. And it made me think that what other features are there like this? What are the dynamic languages in the world actually providing for us? What can we do if we use them instead? So I thought, let's learn Ruby, Python, Lisp, all of these. And yeah, I was just disappointed. They didn't really do what I expected them to do. They didn't use the full potential of being dynamic, so to speak. Let me give you some examples. The top is JavaScript, as you probably notice, and the second piece of code is Ruby, and the last one is Haskell. And well, Ruby and JavaScript is a little more bloated than the last one. And why is this? You could reason as much as you want about why it looks like this, but the fact is that you can't change it. You can't alter JavaScript to get a behavior like the Ruby line or like the Haskell line. You're stuck with function. You're stuck with return. You're stuck with the parentheses and the brackets, or the curly braces, I mean. It's impossible to change the language itself into accepting something else, even though why is it that way? Why does it have to be like that? And then we can look at the operators. Well, in JavaScript, you can't really do anything with operators at all. You can't define your own. You can't change them. You can't really change the syntax of JavaScript in any way. And these two operators are particularly nasty because they do lazy evaluation or short-circuiting, if you will, which means that the OR operator will not evaluate its second argument if the first argument evaluates to true. And that is also something that's impossible to do yourself. You can't create that behavior unless you add a lot of sugar, like you wrap it in a function and make it a lot more complicated. Why? And then there's this thing. Everyone keeps yelling that all these modern dynamically typed languages, in them, everything is an object. Everything is an object. I can manipulate the strings, the numbers, everything. But everything is not an object. I'm not sure what your definition of everything is, but my definition of everything is everything. In JavaScript, function, the keyword function, that's not an object. The parentheses, the dots, these things are not objects. They could be. If the function keyword was an object, we could assign it to something. We could say f equals function, and then we could write f when creating functions rather than writing function, which would be a lot easier. And well, we can't. Everything is not an object. So I actually changed my mind when it comes to thinking about what a language can do, what's a good and a bad language. Because instead of thinking like, let's call the language blob. If you've read anything by
Paul Graham.
Yeah, exactly, by Paul Graham, thanks. You recognize the name. So this is my anonymous language. Instead of asking yourself, what can blob do? That shit, don't ask that question. Ask yourself, what is it that blob can't do? Because if you see what a language can't do, you start like discovering what's possible. It's hard to make up new scenarios if you don't think that way. And also, I think it's not very easy to design a language by sitting down and thinking, what do I want to do? Because it's not about a particular solution. You're not trying to solve a particular problem. You're creating a programming language. That's like the most generic thing you can build. The language will be used to build a framework, which will be used to build an application that someone else will use, and so on. The language is at the very bottom. It should be as generic as possible. So you can't really put a task to one guy or girl to like, create a programming language and think of all the kinds of scenarios that all we as developers will want to use it for. You can't do that. You can't solve a particular thing. That's the job of a framework. So instead, it's about doing as little as possible. Do the easiest thing you can. And that's not easier, actually, because what you have to do is that you have to find the set of primitives that are the most generic ones, that allows someone to shape your language into whatever they want to use it for. And they have to be as few as possible, because the more things you put into the language, the more you encode like ideas and concepts and everything that you want, like the way you want the user to think, or the programmer, I mean. So if you don't put a lot of stuff in, you don't force the programmer to behave in a certain way. And that's kind of the main value, as I see it, of a programming language, that a dynamic language, or, well, preferably any language, but it has to be dynamic to satisfy this, is that it should be malleable and moldable, which means that you should be able to change it into whatever you want. If you don't like writing function when you create your functions, then you should be able to change that. And you should also not just be able to, everything should not be fluid all the time, like water. You should be able to fix it when you want to like make something fixed, which is exactly what I mean when I say that it should be moldable. So a language should be like a dough. You're like massaging it and making something out of it, but it's not predetermined what that is. And that's actually the best part. The best part with a good language is that you don't know what the best part will be, because you leave that up to someone else to decide. They can use your dough to create something awesome themselves. And this is where the fact comes in, that you as a language designer cannot create the perfect solution to everything yourself. You have to create something that others can change to actually map onto a problem and solve something. So now we are wondering, this conference is about JavaScript. Who brought this guy here? And what is he talking about? There's 3 reasons why I think that these questions are interesting when it comes to JavaScript. When you try to like think of a new language, think of what you would like to do. And the first one is regarding what the language does and what it should do, what it shouldn't do. And I mean, JavaScript is just so full of shit. So there are so many bad examples, like don't do this, don't do this, don't do this, don't do this. Very, very much to learn from. And secondly, and this might be the most important point, is that currently it's like a platform for everything. And now I'm using everything in the same sloppy sense that everyone else is using everything, because it's not a platform for everything. But when you're doing web these days, you have to work with JavaScript, because JavaScript is the only language that runs in the browser, and more things come to the world of the browser these days. So if you want to make a new language that targets the browser, you will have to think of JavaScript. How will this new language play with JavaScript? How can we make them interact with each other in order to reuse all that's already out there? And third, JavaScript actually has some amazing ideas. It contains a lot of good stuff, like functions are first class, objects behave like hashes or hash maps. You can look up all the properties and functions and everything like a hash. And it's very tiny in general. It's not a big bloated language. And the prototyping is, at least to me, a more pure idea of inheritance than the classical model employed by Java or C++, because you can build something that behaves kind of like classical inheritance using prototyping, but you can't simplify the classical model if that's what you have. So it has a lot of good ideas. And I think that will play well with a new language that you could create that embodies these new ideas. And the new things that I'm thinking of, the primitives that you would really want in a language to make it really really dynamic, really moldable. Those are three things as well. And the first one of those is to have call by name instead of call by value or call by reference. And if not all of you understand what that means, it's passing a value to a function like a copy of the original value. That's call by value. Call by reference means that you pass a reference to the original object. And call by name means that you pass the actual name of what you're sending in, the symbol or the expression itself, which allows you to do things that don't evaluate immediately. But for example, think of this like kind of pseudo-code-ish JavaScript code where we have a lazy function which doesn't evaluate its arguments when they are first passed in, but rather can use some kind of execute statement to actually evaluate those. If we had that, and well, if we had could assign values to operators, we could implement the AND operator ourselves, because we would not have to evaluate B if A is false. And the cool thing is that if you have this functionality, you can implement the regular one. Because if you just take all the arguments and start by evaluating them left to right, you get the regular function behavior, like everything is evaluated before the function starts. So this is a more generic primitive to construct your language from. Secondly, we need operators. And I don't just mean having operators like in JavaScript. I mean operators on freaking steroids, so they can do anything you want. Or not anything, but more things. I took this example from well, Ruby or CoffeeScript or other languages that has the unless statement. Maybe you've used CoffeeScript and seen this. What it means is that we will assign V to be A plus B unless X is larger than Y. So that's kind of an operator. A lazy one again. It evaluates the right part first, and then it runs the left part if, depending on the truthiness of the right part. And in CoffeeScript, this has been like put into the language. They have entered the unless statement into the grammar of the language itself, which is exactly the wrong way to do it, in my opinion. If you really want an unless statement and you have to create a new language to get it, what does that tell you? That you're not really solving the problem by doing what CoffeeScript does. You're just saying, I have a better idea. I will provide the people with this solution, and they can use that instead. And if that idea is not awesome, or someone else has a good idea, well, then you're screwed again. You haven't solved the actual issue. So what I would like to do instead is to be able to say that at runtime, like I want the word unless to behave like an operator, and I want it to evaluate either the left or the right side first, and I want it to have this and this precedence, so it gets executed before or after other operators as I want to. So it's, when it's actually run, turns into something that looks more like this. Not actual code again, but just so you can think of what it does. So unless would then be a method on the Boolean type. So as long as you define unless as an operator and you create a function that's called unless, it will be invoked, well, like this, if everything works the way you intended it to. Sorry. So that's exactly one. Can you hear me well now? Is it good? It's okay. Thank you. So this is the thing. You have to find the primitives that will allow you to create the new features that you want by not creating a new programming language, but bending the one you have into a new shape. So that was call by name, and it was operators. The third one is syntax unification, which is what Lisp excels at. This is like the whole thing that is Lisp. Everything looks the same. You have your parentheses, and that's it, and you can play with them. The bad part about Lisp is that you have to play with the parentheses. You can't add operators. You can't make things that read better than a whole bunch of parentheses and, well, just lots of nested statements. But we still need that part as well, because then we would have the possibility to actually implement something that looked like this, that I showed you in the first code example. If filter would be a function that was taking its arguments in the lazy way and not just evaluating them right away, this would be okay to begin with, because it wouldn't evaluate the argument. The argument is kind of invalid, so it's not okay to evaluate it. But when it passes it to the function, it should not just pass like the string greater than 0. It should parse that as if it were a program, which we want it to be, and create something like this. Like, this is a message, and it has a name, and it has a list of arguments, and the arguments could be new messages doing new things. It could be a whole friggin' program in there. And then you pass that to the function. And instead of saying, like, execute, evaluate this, this statement or this expression, you send the expression to an object. So here we're implementing filter by creating a new empty array and looping through this array. And for each element, we send this this expression that we received to this object. So E becomes the target of the expression we sent in. And suddenly it's meaningful. E greater than 0. And if it is, we push it onto R and, well, return R when we're finished. So as long as every statement in the program is parsed to a syntax tree like this, or something like it, and not just looked upon as a piece of, like a string, which we have in JavaScript with the eval statement. We can pass a string to it, and we can evaluate arbitrary code. But if we actually parsed it and got the data as it looked, we could manipulate it in more meaningful ways, and we could change things a lot in here. We could not just send the message to a target object, but we could manipulate the message first. We could change the 0 in the argument to something else, or we could reshape it in some other way. And as you see, I don't really know what we could use it for, but that's the point. It gives you power to do things, and it gives you the power to make up what you should use it for. It's not my job to say what you should do with it. So that's the third point. So to start like wrapping up, we're not really there yet. We're not using the full potential of dynamic languages. We are just like scratching the surface. And I think the reason is most of the languages we use today were developed quite a long time ago. Like JavaScript is like 16 years old now. Ruby was created in the beginning of the 90s. JavaScript, Java as well, even if it's not one of the dynamic languages. And that age put certain restrictions on the performance. People thought that, well, it has to at least be kind of fast, but we know now that there's room for different languages. There's room for options. I mean, everything we use don't have to be performant all the time. If it would have to, we would still be using assembler. So when people say, well, what about safety and what about performance? I just say, well, safety, go back to using Java. Come on. If you don't want to shoot yourself in the foot, you shouldn't even be using JavaScript to begin with. The same thing applies here. If you want safety, you create it yourself. You write tests. You follow conventions. You learn from others. You avoid the troublesome parts of the language, and so on. If safety is what you want, don't use a dynamic language. And if you use a dynamic language, stop caring about safety. Don't say, it's not safe if you can manipulate everything and change everything and no one understands what you're doing. That's just not valid. And then as for the performance, like I said, performance, it's just a matter of time. You can't really, it's going to be optimized over time. Compilers become better, our hardware becomes better. We're always taking new steps. So we would still be doing like assembler or C if we never thought about new languages. So once again, don't ask yourself what your language can do, your current language or your ideal language. Ask yourself, what is it that I can't do? What would happen if I could do those things? Because let's face it, every programming language today is Turing complete. They can all solve the exact same set of problems, except changing themselves. Only a truly dynamic programming language can do that. Thank you. Two things. If you're interested in seeing what's becoming of these thoughts, follow me on Twitter, and I will keep you updated. I promise there will be something open source very soon. Secondly, I would love to answer all of your questions, but I think it's much more interesting to take a while and discuss it. So just come up to me after this and ask anything you want, and we'll talk about it. And all of you can do it if you want to. So thanks again.